In this video we're going to take a look at the crime challenge on HackTheBox. It's a medium miscellaneous challenge and the description says please help them. So I haven't completed this challenge yet. I do know what it's about. I'll explain a little bit more in a second. Let's just download the files first of all. So we'll do our basic file checks and we'll see that it's an MP3 file. We can have a look at the strings and see if anything shows up in the plain text. We can see that we do have a some text here saying follow on Twitter. It's probably from the exif data. You can check that with exif tool. So we have the name, crime report, and then yeah, we had this in as a comment. So, and also as the artist as well, and the album. So that's some of the text that we're seeing there. Okay, so let's try to play the audio file and see what. Okay, so in playing the audio file, it sounds like it's been reversed. We can use a tool called SOX to reverse this then, and do a lot of other operations, which we may do some more in a video. Let's first of all use SOX and pass in crime report, and then we'll give it an output reverse.mp3, and then the operation is to reverse. We get an error about the file extension, so we're going to need to convert it first from MP3. So we could do that with a variety of tools. I'm going to use, we could actually probably use SOX for it actually. Alright, I'm going to use FFMpeg here anyway. You probably can do it with SOX, I'm not too sure. So we'll do FFMpeg-I, we'll take crime report and then do -AR 1600, sorry 16,000. That's the megahertz, -AC 1, and then our output, which we'll just call crime report.wave. Oh, I missed an F from FFmpeg. Alright, so if we run that and then check our files, we've now got crime report.wave. So let's go back and do the reverse again, but this time do it with the .wave. And now we've reversed the file, so if we play this again.
Hello HackTheBox players. Someone took the corpse of Mr. Renee. Location. We don't know his exact location, but a woman who witnessed the event told us the coordinates of nearby points. The first one is located at 141 quintillion 205 quatord decillion 953 tridecillion 975 duodecillion 711 billion.
This is giving some coordinates of very large numbers, as you could hear there. So we're going to want to try to convert this from speech to text. So actually, although I haven't completed this challenge yet, I was working on this previously and I'd found a speech to text converter. In fact, went through a couple of different options, and I hadn't actually reversed the audio file beforehand, so obviously it was getting nowhere. So I'm going to go through the same process. As I say, I still haven't solved the challenge yet. I'm going to go through the same process that I had got to, and I used the Vosk API to convert MP3 to text. Initially, I also used the IBM Watson program, because you get 500. You can sign up for a free account and use 500. You can translate 500 minutes, I think, worth of audio a month for free on it. So this is the guide that I followed for setting up the speech recognition. So this is the FFmpeg command we just used to convert to a WAV file, and then you need to pip install Vosk. I've already done that, although actually let me activate my Python virtual environment again. Source pyenv3. So just make sure you pip install Vosk or pip3 if needed. I've already done that. And there are a couple of different models that we can try out. So let's pull this down. Let's git clone the Vosk API. And as it says, we'll cd Vosk API Python example. We can grab this small model, so we can get a bigger one as well and compare the differences. But let's first of all grab the small model. We'll unzip it, and then we'll move the model to model. Now, if you want to test this out, we can do Python test simple and test.wave to result.json. Let's go first and actually have a look at what the audio file. Let's go and test the audio file first. So we can go Vosk. No, wait, what was it? Example.
10001 902 01803.
So it's reading out some number.
10001 90210
1001 90210 something or other. And then if we run this through the program here, it might take no, it doesn't take long to run. I suppose it's a short audio file. And then we can cat out result.json, and here it gives you some, so it's showing partial as it's going through. You see it didn't get the first word, it's got what 00 instead of 100, and you can see that in the results it shows that the confidence of it being a what was actually 0.85, so 85%, compared to the confidence of the other values where it said we're 100% confident that was a 0 and that was a 1 at the end. So it may give you some different results as well. So let's try this first of all with our reversed file. Let's do /// reverse, and let's save that to result.json. Okay, so we'll print this out, result.json, and let's actually open that up because it's a large file. And you see here we have the partials. What we want to look for here, if we look for text, it'll give us the full. So here's the HackTheBox players. Someone took the corpse of Mr. and need these cards in undisclosed location. Let's go to the next text. We don't know his exact location. Let's put on word wrap as well. Don't know the exact location, but a woman who witnessed the event told us the coordinates of nearby and point. The first one is located at 141 kinda silly and 205 quiet or disillusion. Okay, so it's probably, yeah, so we can, I guess, fill in some of these the words that it got wrong there. The confidence is 1 on, you know, the 7 and the 100, and is quite high. So, but we should be able to find the his has got 0.2, the 0.5 here for Julian, 0.2 for Jewel. So that's quite good. It means we can go through quite easily and see which ones need to be fixed up. So we have that, and then this is the same. We've got more numbers than here. So we're going to need to try to transcribe these into a more into digits. So let's also, before we do that, let's try out another model. there's another model here which is 1.4 gig rather than the 36 gig that we just used. So we can go to the models here, or we can just wget this. Oh, wget was already in that. Gonna take a little bit longer to download. While we're doing that, let's have a look at this IBM Watson speech to text. And you can set up, as I say, I think it's 500 minutes a month here with a free account. You basically need to set up the account, and then you get a curl command, which you can send off using an API key and a custom URL and some options to say which model you want to use and what formats you're sending and things like that. Okay, we'll do that shortly though, to try and compare our results to what we're getting from the Vosk here. So let's do this again. Let's unzip. And this is going to take a little bit longer. Okay, that finished, so let's move our Vosk model EN-US Aspire to model, and then let's run the same test again, but we'll call it big, just because we're using a bigger model, and that might take a little while to run. So while we're doing that, let's check out the IBM Watson. So we go back to our IBM Watson. We can, if you set up an account here, I've already set one up, so I'll log in. Alright, so we get logged in, and it's gonna try and make me pay for stuff by the looks of it here, which I'm not interested in doing. So we have our service names, text to speech. That's not what I'm looking for. I'm looking for speech to text. Speech to text. There we go. Okay, and you can so basically you need to set up a URL here. Let me go to the getting started page. The getting started will give some setup instructions, and we'll see here that there's a curl command. So you do a curl post command, we give it an API key, the type of audio file that we're sending. You can do audio/wave, that's fine. -- data binary with a path to our file, and then our URL, which we need to get from, where does it say the URL? You need to go to manage, show credentials, and then grab your API and URL values. So obviously I'll be blocking mine out. And then we'll pass in this post command. So let's grab this command. We can also send that some parameters as well, so we can enable timestamps and max alternatives, and then it'll come back, and for each word it'll show what time that word started and what time that word ended, and you can say how many alternatives, as in like in order of the most likely, what were the transcriptions. So yeah, let's grab the curl command. We'll just take this one and create a new file. Just going to prepare this command. Okay, and in here we're going to put our URL. In this case, I'm going to save my URL as a environment variable, local variable, and then the API key will be the same. API key, we're going to be sending it a wave file, and we'll run it from the directory that it's in. So we can just say reverse.wave. And this is the command we're going to run. I'm just going to go and set up my API key and URL, and then we'll run this. Okay, that's the environment variable set up. We also need just remove these curly braces out of the API key. It says here on the documentation, omit the braces from the examples. They indicate variable values. So there we go. Let's paste this in and run that, and hopefully it might take a little while to come back with a result. While that's going, let's have a look at our big result. So let's search here for text again. And we want to see particularly the numbers, how the numbers are looking. Let's view this with a word wrap. I really need to set this on as a default. That's not word wrap. Oh, there we go. This is looking, that looks better from what I can see, although acetylene. So we're just going to need to go through and I mean, we can go through and manually fix whichever ones we need to. I mean, they do get quite long. Let's go to the next text result. Text. Okay. What was the final one? I hope you could help with this matter. Alright, let's see if we can, let's see if the IBM Watson result is back. It is. So we can compare this. Hello HackTheBox players, took some time. This is looking better already. Told us coordinates and nearby points. The first one is located at 141 quintexillion, 205 quad or decillion. Okay, yeah, that's a long. These are some long numbers. All right. Nearby points. Okay. In this case, we have these. You see the confidence there is 0.97 on that. Okay, so it looks like this is probably going to be better for us, but we can compare the two of them. Another thing we can do as well is, let's go to our reverse .wave.
Hello HackTheBox. In 284 run decillion 586 decillion 4 in 188 octillion 611 septillion 150.
We can slow this down as well. There are a few tools. We could use something like Audacity, or we can use play it slowly, reverse, and if there are any parts of it that we want to slow down or we want to repeat and things like that.
Or decillion 953 decillion 975 duodecillion 452 undecillion.
So we can do that. Let's take these strings then and try to convert them. These have got high confidence 0.97, but there might be some words in here that we need to manually sort out. So what I'll do, we'll take a copy of this to work with for now. I'm gonna take that, we'll create a new Watson.json. Oh, wrong place to paste. Paste that there. I'm gonna save that, and then I'm gonna run this again, but let's pass it the command to check for alternatives. So we'll do max alternatives, we'll do timestamps as well. I'm gonna add that to the URL, and then we'll do -o to Watson full.json. Try that. Hopefully that outputs correctly. This will just mean that we can go through each character individually, and each word individually, and any that are like less than 100% confidence, we can just transcribe those. which I think makes more sense than going through manually and trying to find out which ones don't match. Let me put the word wrap on. And let's see then if we can find a tool or put together a script or something to convert this. It's going to be easy enough for us to convert these strings to numbers, but it's just then inserting the required number of zeros. We maybe need to do like a dictionary mapping or something. Let's have a look at this as well, the Watson full. Yeah, okay, so it did. Yeah, it transcribed those, and you can see for each then word it has the start and end time of the word. It doesn't have the confidence of each word though, which I was expecting. I was expecting us to give us the confidence of each. It also gives us the alternatives, so it'll give us 3 alternative transcripts for each of those. Okay, cool. So I went through off camera there and transcribed some of this. So I essentially took what we have here, and you can see that the first one is located at. We can look for then the second one is located at, and then finally, oops, the third one is located at. I then also had to just go through manually and listen to it and play it slowly at about 75% of the speed, just to try and find out where was the break in the middle of each set of coordinates, because we have an x and a y in each coordinate, as was indicated in the text where it says here, hello, coordinates of nearby points. So I just had to go through and listen to where the pause was in order to separate those. The other thing was some of the words didn't translate properly. So we had this quatrodecillion. If we have a look in here, where is it? Quatrodecillion. It's after 56. Let me search here. 56. So you see here quad or decillion. So I had to go and just change anything that said quad or decillion. I changed to the correct value to quatrodecillion. And then there was just a couple of other issues, like there was a 1 at the end of this sentence which it didn't pick up and stuff like that. So I went through the whole thing, just listened to it manually and got those separated. Now what we need to do is we need to convert these into actual numbers. The way I was thinking about doing this was essentially grabbing a mapping of like digits to numbers. Well, I was actually thinking of using there's a Python library, Python word to number. The problem is it only deals with numbers up to 1 billion, and then the other issue is we have here 2,003,000. So it would work with that up to 1 billion, but obviously here we have 175 quindecillion. So another possibility, the problem is if we just convert these, that'll convert to 100, and then this would convert to 75, so that'd be 10075. So it's not just as easy as just converting these to the raw numbers. Another possibility is to separate these by the suffix. So the suffix here, quindecillion, we could say 141 quindecillion, and then we could say 205 quatrodecillion, and then 953 tredecillion, and then 975 duodecillion, and then essentially we'd just be putting plus at the end of each of these lines, and we'll convert these into the integers, and then we'll just perform a calculation to add those all together. So that's kind of the best way that I'm thinking about doing this at the moment. The other, yeah. I'll look to see if there's anything else we can do, if there's any scripts available online, just to kind of automate some of this. But, what I just described there I don't think would take too long. And although it's not as automated as I would like it, I think even with that bit of manual calculation in there is going to be a lot quicker than trying to find something which is going to properly automate this. You know, there's a reason that there's no tools available for us to do this. So that's our next step, is to convert these into their integer representations of the coordinates. Okay, so I've taken some time to think about this and to research some possibilities in terms of scripting this, and I believe I've come up to a reasonable solution. So I found this link here, how to convert a string describing time into seconds. And the reason this looked good to me, or the reason I wanted to use this, is because somebody had created a nice dictionary here containing a lot of stuff actually, and this is quite handy in terms of they've written a script to, for example, take in 1 billion hours and 12 minutes, and it'll return the number. And that's not actually based on the time. The time is just down here that they're doing the time stuff. So it's the parse int is where they're actually parsing the words and returning them as an integer. But there are some issues. One, this is assuming that it's not going to be past a huge list of things. So it would take quite a lot of modification to get this script working for us. I'll throw it in the description anyway if anybody wants to have a go at it. Please do be my guest. But here's my thinking for solving the solution. I'm going to grab this powers dictionary and I'm going to paste this in here. Okay, let's save that. Just get the formatting sorted there. Okay, we'll save that there. And then, what do we want to do here? Well, my thinking is essentially, if we can split on these powers, excluding the 100 and the 1000, then we should be able to basically do a sum. So let me try and give you an example. If we say we want to split on quindecillion, all of these suffixes, what we can get is we would get this into a string and this into a string, and then all we need to do is multiply this by this, and the 141 we can just convert the text into int using this cool word to number library we found, because this will process words that are up to 1 billion in size. So essentially, we can go through and we'll extract 141, we'll multiply it by quindecillion, we'll extract 205, and we'll multiply it by quattrodecillion, we'll extract 953 and extract it and multiply it by tredecillion, and etc. So that's my thinking here. So let's, just before we put this into a loop and loop through all of this, let's just test it out with like the first element here. I'm going to rename this. Set list. Okay, there's a couple of things we need to import as well. We need to import this word to number. So install this with pip install, and then we'll just paste this into our imports at the top. We're also going to import RE to do the regex split. And we're gonna say import numpy as np, and that should be good there. Okay, and then right here let's do a string split. Let's say split string is equal to re.split, and in here we're gonna give coordinates set list, and we'll just give it in the 0 0 to begin with, which will be the 0th element and the 0th element of that, so just this string here. We're just going to test it with this to make sure it works. So that's what we're giving it. We also need to give it then the string, so this is what we want to split on, and what we want to split on is essentially this list right here. So let's take this list. We don't want to split on the 100 or the 1000 because obviously we have 100 here, so if we don't want to split on that, we want to be left with, at the end we'll have, in this example, 100, 400, 400,000, 403. So we're splitting every suffix or every power until we get past this million at the end. Hopefully that makes sense. I don't know, it might be a little bit confusing. Essentially, because this million shows up throughout here, and the 100 shows up throughout there, etc. We have to be careful. Right. Okay. Try and grab this. Let's put this in to Sublime. I'm going to paste this in here. We can do Control and H to do find and replace, and just make sure you have regex enabled. And then we'll say backslash. We want to extract this. So backslash word plus. You see, it's got those selected, and then there's a quote. There is a colon, space, and then actually, can we just do dot star? We might be able to just do dot. I'm gonna just right. 1 second. We'll do that. We'll do dot star, and then oops. Yeah, we'll do dot star, and then we'll replace it with 1. Let's just see how this looks. That looks good. Now what we want to do is we'll change the indentation, and then I want to replace the new line with a pipe. I want to replace them all. We want to get rid of the 100,000 because in some cases we're going to say there's 100 million, but we're never going to say there's a million billion or whatever. Do you know what I mean? We're only going to be using the 100 and the 1,000 throughout. So we want to take those out. All right, and that's it. Let's grab that. Let's take it down here and throw it inside here. Put it inside brackets because we want to make sure that this is extracted as well. We don't want to split on these values, but then not keep those values. And notice most of these values are never going to appear. We could actually just go through and see which ones of these are we actually going to use, but let's write this in a way that it's actually reusable for potentially other CTF challenges that might use this full range. And there we go. Okay, so we're doing the split. Let's print this out and see what it looks like. Print split string. Okay, let me minimize that just so we can see it a bit more clearly. I'll clear this off screen and we'll do Python transcribe. And you can see this is printed out and we have 141 quindecillion, we have 205 quadradecillion, etc. If we go back and say let's print out the length of that. Print out the length. We'll see that the length in that case is 29, which actually isn't right. I went through this just trying to work through this script beforehand and realized that they missed the trillion in this list here. So if we go to large numbers table, just spell it however we want, it'll find something. Or no, it won't. Large number table of large numbers, and just see what we've got here. Trillion, 10 to the power of 12. So we can go back to our script here, and we want to put in, we want to add the trillion here. Trillion, 10 to the power of 12, and then we also want to make sure that the regex is looking for trillion as well. So just add in trillion here. And if we run that again, we now have 31, which is awesome. The issue here now is that we're going to be left with a uneven array. So what I think's the best thing to do here is create a 2D array. So we'll create numbers 2D equals numpy.reshape, and then we pass in not reshape. We pass in our split string. And then we say how we want to reshape it. If we do -1 here, it will take the size of the input. It will base it on the size of the input. So if we do that, try and do that, and then print numbers 2D, and you'll see we get an error because it's an array of 31. We can't divide 31 by 2. So what we want to do is pad out the value. Let's say split string dot append, and then we'll just say none. Okay, And you'll see here now we have 141 quintillion, quindecillion. We have 205 quadradecillion or whatever. 253 tridecillion. 275, etc. We've got. It's looking good. It's looking good. The only thing is at the end we have this 104,403 by none. So my idea is go through each one of these, convert these to numbers, and then multiply these by the mappings that we have for the powers. Obviously for this one we're going to be multiplying not by none but by 1 because we want it just equal itself. So let's go and create a new index here called none, and let's set it equal to 1, and that means whenever it comes to that it'll just do 1 times that. Hopefully this is making sense so far. Let's loop through this then. So we'll create a total, set it to 0, and then we'll say for prefix and suffix in numbers 2D, the prefix being 141 and the suffix or the power being quindecillion. So we're going to say for the prefix and the suffix, what we want to do is we want to set our result to equal, and we need to convert word to num. Oh, it's not giving me a... doesn't give me an autocomplete there, that's interesting. Well, you can see from here, we import it and then we can just use w2n word to num, and then we pass in our prefix. We'll also need to convert it to a string because it'll be a numpy string, so we'll just pass in a prefix there, and then we want to multiply that by whatever we have in here. So we'll say it's called powers, so the powers dictionary, and the key that we want to look for is the suffix that we're currently processing. So in our example, it's going to take 141, it's going to pass it to word to num, which is going to convert it to 141 in digits, and then it's going to multiply that by whatever it finds in the powers table under this key, quindecillion, which is up here. So it'll multiply it by quindecillion, it'll multiply it by 10 to the power of 48. And then it's going to assign that to the result. So then we're going to want to say total is plus or equal to, and we'll just make sure it's an integer, result. And then it should be a case of just printing out the total. And if we run through that, you see that we've printed out a nice long number. We could go through it as well. Let's just go through and say print str result as we go. You see it's printing out those results. We could have also print these out as well, just to make sure all the conversions are happening correctly, but it looks like they are. So what I'm going to do is just adapt this to loop through each coordinate and add some comments here. Okay, so I've just modified this. I've just added in some comments, and we're now, instead of just processing the element 0, 0 of the coordinate set list, we're looping through each set of coordinates in the coordinate set list, and then we're looping through each coordinate in that coordinate set and performing that operation, and then at the end we'll just print out the result of each coordinate. So let's try and run that again. And we now have our 3 sets of 2 coordinates, all long numbers. There is a slight, I noticed that they're not all exactly the same length, so we might have to go back and see if there are any problems in that way. Also, no, that looks okay. So yeah, there might be some issues with the numbers. Let's find out. I went through a couple more times there just with the transcriptions to make sure those numbers were correct. What I did is I printed out some debugging information, so whenever we run this, if we run transcribe, it'll show for each set of coordinates, it's going to show exactly what it's calculating. So if we go to play it slowly, and then we can run this in the background.
The coordinates of nearby points. The first one is located
And
at
just trace it here.
141 quintillion 205 quatorticillion 953 tridecillion 975 duodecillion 452 unticillion 735 decillion 590 nonillion 496 octillion 324 septillion 65 sextillion 85 quintillion 441 quadrillion 984 trillion 552 billion 429 million 104,403 379 quintillion
So let me
570
stop that. So I went
quatordecillion
through with all of them there. There were some issues, and I quickly found the issues by some of the nonillions were down as millions, and it was quite easy to determine because if you go down this chain, you can see each time we have 2 less zeros. So we had 2 less zeros, 2 less zeros, 2 less zeros, and then whenever it got to the nonillion section, we only had 6 zeros, like the million here. So you can see, even just going down through this, that it's got all the powers in the right place, all the suffixes. And I went through manually again many times, comparing the numbers at the beginning and then making sure that this calculation is done correctly. I mean, you can see here 2 1 quintillion. We have the 2 1 here, and then 947 quadratodecillion or whatever. We have our 947 here. You know, it's all Python's doing all the calculations for us. There's nothing really to get wrong as long as we're transcribing it properly, which we definitely are now. The description, the challenge as well, it said at the end, well, let's have a look at the beginning. It was saying that the corpse is an undisclosed location. We don't know the exact location, but the woman who witnessed the event told us the coordinates of nearby points. So we get the 3 sets of coordinates of the nearby points, and then it says at the end, the suspect leaves a letter to Mr. René Descartes' family to inform them that they need to bring a ransom money to the location where the shape formed by these 3 points is incomplete equilibrium. I hope you can help with this matter. So it's basically saying that we have 3 sets of coordinates and we need to find the point in the middle of those three sets of coordinates, and that's going to be where our flag is at, essentially. So to do that, I've added the Centroid calculation here, where we pass in the coordinate set list which we're generating. So this is the results of going through this processing. We pass that in and we get the mean. I've also tried putting these coordinates into a few online tools for calculating the Centroid and stuff as well, just to make sure that it's definitely working correctly. And it seems to be they all come back with consistent results. This is the results we're getting here. We have the final results. I've tried basically accessing these on Google Maps as coordinates, the longitude and latitude. If we go to, let's go and have a look here. Search for coordinates on maps. So you see, let's go to the Google support, and it says we can enter it in as decimal degrees, so 41.4 or whatever by 2 point, etc. So we can go try and play around with those, and let's go to Google Maps, and then let's take this into our Sublime so we can see what we're doing. It has the plus 50 at the end, so we can take this off, or we can, let's go back and print out, if we print this out at the bottom, converting to ints, we can also get the full length here, but it doesn't really seem to make much difference in terms of looking for the coordinates goes. So if we don't put a point in here, then we're not going to get any result at all. Let me put in a point. Oops. We'll paste that in. And you'll see this takes us to North Atlantic Ocean. There is a picture here of a whale. Which is pretty cool. Nearby picture anyway. And it's off the coast of Nigeria. That's not showing Nigeria. For some reason it's gone back to... But if we zoom out here, then we'll see, yeah. So, you know, that's not looking too good. I've tried playing around with this in terms of moving the decimal points around. Where's the next bit start? Again, takes us to another location, but I mean, it's no closer to getting a flag. So what else could we do? We could take it to ASCII to hex and see if we can do some conversions here. So we can, let me paste in what we have here, because if we paste in this full number as a decimal, we'll just get it's too big. But if we paste in these numbers, we should be able to get a representation. So paste that one in there. We get this as a result. And then if we do the same with the second coordinate, paste that in there, and we get this as a result. So I tried as well playing around with these. So in terms of if we join these together, unfortunately they're still not long enough to 27 characters. It doesn't match our typical length for a hash. Similarly, if we do things this way around, I've tried appending the 32 and the 1 on each side. So I tried it like this, and then similarly like this. And I've been through trying to convert it through different formats. Been in CyberChef, running magic on it. Yeah, we really don't seem to be getting anywhere. So I'm not too sure where to go from here. So I'll keep looking into it anyway, and hopefully come to a solution soon. I mean, it seems like we're getting our numbers correctly there, so it must be to do with me just not knowing where to put these final values. I've also tried adding these values together, but yeah, getting nowhere. Okay, I identified some issues with the Python version. So whenever we're calculating the centroid here with NumPy, the result that we get is the same result that we get if we use any of the online tools. And I went through, if we go to, let's double check the how to calculate the centroid. So we add together the coordinates, all the x coordinates, and divide them by 3, and we add together all the y coordinates and divide them by 3. So that's what this function is doing here anyway. We're using this 0 axis to do that. But I tried to do this manually as well, just manually add these together, divide them, and then print out the x and the o. So let me run this. Python transcribe, and we'll see that with NumPy, the numbers that we get here are exactly the same numbers. However, if we now activate our Python 2 environment and then run that again, you'll see that the number we get in NumPy is different. You see here the number's completely different to the number that we get in just in Python doing the calculation. So I tried fixing this. I don't know how you can fix this with NumPy. I tried changing the D type, but I couldn't. Everything I tried just got back to the same results. And we can verify. We can say let's print OX minus the Centroid, and if we print that, you see that it should be, we minus those and we should get 0, but we're not getting 0. So that's that issue resolved. We're now getting the correct values through Python 2, so it's just worth bearing in mind. If you're having problems with the numbers, the maths at the end, try to run it in Python 2, try it manually without NumPy and see if that gets the correct coordinates. And it looks like we have the correct values now, so let's try and work out how to convert them. Okay, I spent a while trying to convert these values, and I'll show you some of the problems that I've been having. If we go to ASCII to hex and try to convert there from decimal to hex or into text, obviously it's too big to deal with, so I tried doing a similar thing in CyberChef from decimal, and we're not able to do that in there. So I ended up messing around with basically a lot of things. I'll not go into everything that I tried messing around with. What I will mention is that some of the stuff we were doing earlier with coordinates, you can actually use convert coordinate format in here, and you can pass in your values and convert them into different formats. And then you can also pass these to a map function as well, show on map, which is just kind of some of the stuff we were doing earlier with like Google Maps and stuff. So I just thought I'd mention that quickly. But how did I end up resolving this? Well, if we print these out as hex instead of integers, we get these values instead. And if we let's take the first value, and I'll put that into CyberChef. Let's do magic. And you can see here, converts from hex and gets the first part of our flag. So I'll not show getting the second part of the flag. I'll leave that to you. You can have a look at the script. I'll put this script online. I might take this text out of it. I'm debating whether I don't want people just to run the script and get the flag, but at the same time, I mean, it's not really much of a skill to sit and transcribe manually listening to the audio. Do you know what I mean? Like, if I take this out, it just, all that's going to do is force you to sit and listen to the audio file a load of times and make sure you get all of these correctly, which I think the time could be spent better doing other things, to be honest. But not to dig the challenge. I think the challenge was really good. It took me a long time and really frustrated me, but it was a really good challenge anyway. So yeah, I'll put this script online, and you can work away at it, and let me know how you guys solve this challenge. If you solved this already, or you did it in a different way, or let me know if I was doing something stupid this whole time, which I could have done a lot quicker. That's normally the case. And hope you've enjoyed the video anyway. Give it a like, subscribe, all that. Thanks.